This is a nice long toolbox here that talks about assessing damages from natural hazards. Obviously, if you want to worry about financial and macro fiscal issues, you have to do these things. There are few databases with records of past disasters and their human and economic consequences. The most used is EMDAT, curated by the Center for Research on Epidemiology of Disasters at Belgium's Université Catholique de Leuven. Other institutions have created similar datasets, including the United Nations Disaster Recovery, so disaster risks and recovery, I think. Reinsurers Munich Re, NatCat Service, Reinsurance Swiss Re, Sigma, and so on. These datasets allow quick estimates of current country level risk levels, but it is important to use historical and economic datasets with care. They tend to be incomplete, especially for low-income countries and moderate intensity disasters. So they may be better for very heavy damaging disasters where the numbers are gathered just because it gets more attention, whereas the more moderate intensity disasters may not be tracked as closely in terms of potential damages. They also use different definitions and thresholds. For example, what is considered a disaster, and provide economic estimates based on different methodologies and covering different scopes. Some cover only direct costs, while others cover direct and indirect costs. Also, socioeconomic and climate trends make natural hazards non-stationary, and risk assessments based on historical data cannot provide precise estimates of future risks. So the past is not necessarily a mirror to the future in this case because of climate change, obviously, and changes in extreme temperatures, humidities, rain, sea level rise, etc. Governments should create their own monitoring system and keep records of every disaster. These should cover the nature and location of each event, as well as available information on its consequences, with harmonized methodologies and scopes if possible. There are recommendations on how to set up such a system elsewhere, so OECD has a report on that. To assess future disaster risks and their economic implications, governments should use simulation modeling to estimate the direct risk to assets and economic activity, usually expressed as average annual losses. A range of approaches are available for this, from simple, cheap options to complicated and expensive ones, including relying on global estimates to estimate your local damages. For example, the United Nations Disaster Office for Disaster Risk Reduction, DRR, Disaster Risk Reduction, which I said wrongly before, apologies, and its risk and disaster data platforms provide country-level assessment of earthquakes, storms, and floods. Making relatively simple assessments using existing data, combining global hazard maps such as those recorded in the Think Hazard platform, remote sensing based estimates of exposure such as approach based in Gunasekara et al. Paper, vulnerability curves which are available from various sources including academic papers and engineering documents. Vulnerability indices are basically based on many parameters. For example, vulnerability to natural climate hazards can include, in a country like India, even caste, per capita income, the kind of house you live in, the kind of infrastructure services you have, availability of energy, water, information system, and so on and so forth, which means vulnerability indices may not be the same for different hazards and in the same place and across regions. So this is something one has to keep in mind, and keep in mind that the IPCC has followed this risk index, which is multiplier of hazard, some indication of hazard, vulnerability, exposure. This was used in AR5, released in 2014, and in 2021 the AR6 they switched to adding response to it, so that risk is now multiplication of hazard, vulnerability, exposure, and response. Okay, The GFDRR country profiles provide examples of simple risk assessments with estimates of direct damages for different hazards and reporting periods in many countries. So figure G1 will look at the risk assessment for Saint Lucia. Developing a full country catastrophe model. This is a longer and more expensive exercise involving primary data collection, for example, on the exposure and vulnerability of buildings and infrastructure. Commercial modeling firms have developed such models in countries with developed insurance markets, but low-income countries do not usually use them. So insurance companies often want to have a good sense of the risk that they are underwriting, so they do a lot of work, including collecting their own data and doing their own modeling to do vulnerability and exposures. With each of these approaches, it's possible to restrict the assessment to public assets, either by using a public asset inventory or a simple rule of thumb on the fraction of assets that are government owned. This would allow governments to assess the risk to public assets, which will correspond to the reconstruction needs they will directly be exposed to. This work can build on Action 1.1, which we read, which recommends creating hazard maps and data sets. They're called risk maps, which are a multiplication of the things we talked about. Hazard maps are just what naturally occur. Could be earthquakes, floods, droughts, wildfires, etc. Which recommends creating an inventory of public assets, including their value and exposure to natural hazards and climate change impacts. Climate change impacts are tricky, which we have discussed elsewhere. Okay. Figure G.1 then, St. Lucia hydrometeorological risk profile, loss in millions of dollars here. This is from 2018, so whether this gets updated routinely, we don't know. And return period of events. So public economic losses are down here, direct economic losses and total economic losses. And you can see as the return period increases, it means two things. It's a low probability high impact event. A once in 250 year rainfall event will be much more massive than a once in 10 year or once in 50 year event. So corresponding losses go up as well, which makes sense. Figure 15 here, the government of Fiji's implicit contingent liability based on social protection financing needs in response to tropical cyclones. So this is also a bit dated in Fijian dollars. Additional social expenditures and return periods. Return periods is just one measure, but you can do it in many other ways. Fiji is worried about return periods of events based on its historic climate hazards, so that's how it does it. So it's a Winston-like response, so it's a cyclone, wider and stronger response. So this response was not as wide and strong as this one, but you can see additional social expenditures are more than twice, almost 3 times as high here for something like once in 1,000 year return period event of cyclone. Okay, so these are obviously it doesn't mean you have 1,000-year data. There are statistical ways in which you create these probabilities of return periods, and then you can track how the return periods change as climate changes, remembering that climate change basically loads the dice in terms of changing the frequencies. In terms of events like heat waves, it will change duration, frequency, and intensity in many cases, but in return periods, the return events with a return period of 100 may become much more frequent. They have already become frequent in many hazards. So that's how this thing works. Okay. Figure 16 looks at relationship between direct asset losses from hurricanes of increasing intensity and resulting losses in output. So these are indirect losses and direct losses. So you have direct asset losses from hurricanes of increasing intensity, resulting in output losses. Okay, so here in dollars of billions, billions of dollars, billions of dollars. So obviously, as direct losses increase, indirect losses increase, and it's not a linear increase. That's what you have to remember. It's a non-linear increase, which obviously relates to the return periods as well. Okay, so I'll stop this podcast here, and we'll come back and look at additional points in this section on estimating financial and macro fiscal losses to natural hazards. Okay.